To those that are new, welcome. To those that are coming back, welcome back to my YouTube channel.
Good day, everyone. Today, we are going to be talking about trigonometry. This specific video is going to focus only on the 90 degrees triangle. But before we get to the 90 degrees triangle, we would want maybe to look at what are the properties of angles in triangles. Now, one of the main properties that we have to take note of is that the sum of the interior angles inside any type of triangle, the sum, this angle plus that angle plus that angle, should give me a total of 180 degrees. Another thing is that we have different types of triangles. We have what we call the isosceles triangle, and in isosceles triangle is when we have two of the sides on a triangle that are equal to each other. It would usually be denoted by that, or perhaps just an indication telling you that the two sides are equal. When you have that situation, you should know that you have what we call an isosceles triangle. The angles at the base are equal. Another type of triangle is what we call the equilateral triangle. An equilateral triangle is when all the three sides are equal to each other. Now, if all the three sides are equal, then it means all the angles are equal. Now, if all the angles are equal, and we know that inside a triangle, any type, we should have a total of 180 degrees, then it means if the total should be 180, then it means this has to be 60, 60, 60 for it to add up to 180. That I get by simply saying 180 divided by 3, since I have 3 angles, and I would get that each interior angle inside a triangle that is equilateral, that is an equilateral triangle, should give me 60 degrees. Another type of triangle is what we call a scalene triangle. And scalene, I hope I'm right about the pronunciation. However, this is just a triangle that none of the side is equal to the other. So none of the angles will be said to be equal to the other. You know the sum is 180, but you're not sure how much the size would be. Now, another important property of angles in a triangle that we should take note of is if we have a triangle, perhaps let's say that, and we extend one of the lines that makes up one side, we create what we call an exterior angle, an angle that is formed outside. Now, that exterior angle, you can always get it by saying this angle plus that angle, meaning the sum of the opposite interior angles will give you the exterior angle. So let's say I call this angle A, and I call this angle B, and maybe the exterior angle, I'm calling it C. What I just said earlier is that the exterior angle is equal to the sum of the interior angles. So it means to get C, I will simply say A plus B. Or then it means if I know what C is and what B is and I want A, I can always take B out of C, which means I can get A by saying C minus B. So I can play around with this formula. The sum of the interior opposite angles, the ones that are opposite the exterior angle, should give you the exterior angle. Meaning, if I had it like this instead, and my extension is in this line, then this exterior angle, I would get it by adding this and that. Do you get that? If I extend this one instead, I should take note that the sum of this exterior angle, I'll get it by saying this plus that. So you just play around with that. Now, this is just us roughly going through some properties of angles in a triangle that you might want to take note of before we get to study them in details. Now we are looking at 90 degrees triangles, right? Which means it's a right-angled triangle, meaning one of the angle inside that triangle is going to be 90 degrees. An example of a right-angled triangle is something like that. They would indicate that this angle is 90 degrees. If they could have turned it around, as long as one of the angles inside this triangle is a right angle, we would call it a right-angled triangle, or rather a 90 degrees triangle. There are certain things that we consider that are going to be involved in a right-angled triangle. For us to do any calculation in a right-angled triangle, we can label this A and then B and C. Let's call this our right angle triangle. Now, for us to do any calculation, whether we want this side, or whether we want distances around that, or the angles inside, there are certain formulas that we are going to use. We have what we call the Pythagoras Theorem. If we have our right angle triangle, let's say ABC, this longer side, we call it our hypotenuse. And that one that is opposite that right angle is always going to be our hypotenuse. So I'll abbreviate it HYP. Now, to get that longer side, which we can refer to as BC in this case, we have a formula that says BC squared, which is now our Pythagoras theorem. BC squared is going to be equal to AB squared plus AC squared. So this is our Pythagoras theorem. We are using this triangle. I repeat, we say the hypotenuse, which is the longer side squared, is equal to the sum of the other sides, the shorter side squared. Let's study this formula in detail. Let's say instead we have the longer side. Let's say we have what we have. We have BC squared and we want AC squared. Let's say we want AC. Then it means we can say AC squared will be the longer side squared minus the other shorter side squared. So we can play around with this formula and get what we want. Like you just make one of them the subject of the formula. It means you will take from the longer side minus AC squared. If you have to take AC to the other side, then you have AB squared. If you want AC squared, you take AB to the other side, then you have BC squared minus AB squared will give you AC squared. Now, so that is our Pythagoras theorem. You can repeat the video if you have not mastered it yet, but please take note, this Pythagoras theorem is only used in a 90 degrees triangle, meaning a right angle triangle. I have to have a 90 degrees angle in my triangle for me to use this. Another way of solving problems in 90 degrees triangle is what we call our three ratios, known as the SOH. These are our three ratios. Now, these three ratios represent, this one means sine theta, theta representing an angle you do not know, is equal to opposite over hypotenuse. And this represents, or this means, the CAH means cos theta is equal to adjacent over hypotenuse, while TOA means tan theta is equal to opposite divided by adjacent. Now, what are the opposite, adjacent, and hypotenuse? For you to use these three ratios, you will have to have an angle involved. By angle involved, I mean that you have your right angle triangle, right? Then it's either that you are finding one of the angles or that you are going to be using it to find one of the sides. Very important is that you should be able to label your sides. Which one is your opposite? Which one is your adjacent? Which one is your hypotenuse? The hypotenuse is always the longer side or the side opposite your right angle. The adjacent will be determined by the angle that you are using. By angle that you are using is, if you are finding this angle, let's say theta is here, then this angle theta will determine which one will be your opposite and which one will be your adjacent. Please take note that the side that is opposite the angle of consideration, which in this case is theta, that side that is opposite it is what you are going to call your opposite. The side that is adjacent to the angle of reference, I don't know if that makes sense, adjacent to the right angle and the angle of focus is going to be your adjacent. So, hey, your adjacent. Excuse the mess. So I'm gonna redraw that here. Take note, we have our right angle. The right angle is here. If I say the angle of focus or theta is here, then it means this hypotenuse never change. But the angle determine which one will be your opposite, which one will be your adjacent. The one opposite the angle of focus, by angle of focus is the angle you are finding or the angle you have, then that is always going to be your opposite. while the side that is going to be adjacent is going to be the angle, the side that is made up of sort of like the right angle and the angle. That line is going to be what you call your adjacent. Now, let's say instead our right angle was like this. This is and this is your angle of focus. By angle of focus, I'm just trying to say the angle that you have or the angle that you are finding. I repeat. So take note that your hypotenuse will never change. So this one will still be your hypotenuse. Try to pause and determine which one is the adjacent and which one is the opposite, and then you can continue the video. The side that is opposite the angle is gonna be your upper side or opposite, the bamboo in me. And then the side that is going to be made up of the angle and the right angle is going to be what you call your adjacent. You want to practice on being able to identify your sides before you can actually come and try and use these three ratios, because you will need to know the correct side so that you use the right ratio. Now, having now these two formulas, we said in the 90 degrees triangle, we either use the Pythagoras theorem or we use the three ratios. We now need to know, when do we use the Pythagoras theorem? When do we use the three ratios? Remember, I said the three ratios, we only use them when there's an angle involved, meaning you are either finding the angle. When you are finding the angle, it means you have the two sides, or that you are actually trying to find the side, one of the side, given an angle and a side. So I repeat, there should be an angle involved here, because the sine, cosine, and tangent ratios, they only work with the angles. So I need to have an angle involved. And I repeat, and I'm emphasizing on this because I have seen people making that mistake of not knowing when to use this and when not to use it. You only use it when there's an angle involved. When is the angle involved? When you have to find the angle, or perhaps you have to use the angle to find one of the sides, meaning you have an angle and a side and you want the other side, or perhaps an angle and a side and you want the other side, whichever side, however there's an angle involved, or perhaps you have two sides and you want the angle. That is when you use these three ratios, and we are going to explore and see how do we use them. Another thing is that the Pythagoras theorem has nothing to do with the angle. So when you have a right angle triangle or a 90 degrees triangle, and you have nothing, no question asking you about finding the angle, meaning there's just distance involved, you are having two sides and you want the third side, then you know I'm going to use the Pythagoras theorem. And that's the theorem, remember. So you want to make sure you understand this video, and then before we get to the examples, that you know the basics and the theory behind what we are going to be looking at.
Thank you for watching. Please subscribe for more videos.